Postgres ships with 3 practical isolation levels, and each one draws a different boundary around what concurrent data your transaction is allowed to observe. Getting that boundary wrong is one of the most common bugs hiding in production code. Read committed is Postgres' default and re-snapshots on every statement. Repeatable read freezes the snapshot at transaction start. Serializable adds dependency tracking to catch conflicts that snapshots alone cannot prevent. Every query consults the transaction snapshot to decide which row versions are visible. Under read committed, that snapshot is refreshed for every statement, so a long transaction can see rows that a concurrent transaction committed mid-flight. Repeatable read pins the snapshot once, closing that window. After transaction 713 updates the balance, both row versions live on the heap page. The old tuple has its Xmax set to 713 and is considered dead. A transaction whose snapshot predates 713 will keep reading the old version. That is exactly how repeatable read prevents non-repeatable reads. A dirty read means reading a raw that a concurrent transaction has written but not yet committed. A non-repeatable read means the same select returns a different value the second time in the same transaction. A phantom appears when a range query suddenly includes or excludes rows that another transaction inserted or deleted. When reviewing a balance transfer, the first thing to look for is whether the transaction explicitly sets its isolation level. Defaulting to read committed means the pre-transfer select and the update can observe different snapshots, allowing a concurrent transaction to slip in and produce incorrect totals. In this self-contained example, both isolation levels return the same rows because no concurrent transaction is racing against us. In a live system, read committed would pick up an intervening commit mid-transaction, while repeatable read would hold its snapshot and return the values it saw at begin. When you review a pull request, look for any transaction that reads a value and later acts on it. If it does not set its isolation level explicitly, the author has silently assumed read committed is safe, and for anything involving aggregates, range checks, or dependent writes, it almost certainly is not.